Hey guys, in today's video we're going to touch very briefly on Pythagoras' theorem. We're going to explain what it is and how it relates to right-angled triangles, and then we may do a brief example just with a couple of basic numbers, but we're not going to get too much into detail. We're not going to talk about how it was derived or go into proving it. So let's start out firstly by talking about right-angled triangles. What is a right-angled triangle? Well, a right-angled triangle is any triangle which is an object with three sides where one of the interior angles is exactly 90 degrees. So usually we would indicate this with the following symbol in the bottom corner at that angle. And usually we label the sides of a right-angled triangle. Let's label A, B, and C. And that's the side lengths, a variable for the side lengths, where C is always opposite this 90-degree angle. And when we label them in this way, we refer to C as the hypotenuse, which is the, as it turns out, always the longest side. So Pythagoras' theorem states that C squared equals A squared plus B squared. So what does this mean? It means and says that there's a relationship that exists between these three side lengths in a right-angled triangle. And it says that the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides, of the lengths of the other two sides. So if we find the length of each of these sides and we square them, we'll find that this relationship exists. And this is for any triangle with a right angle. So let's have a look at a very basic example for a known Pythagorean triad, which is basically a set of three numbers that fit perfectly into this formula, where each value is an integer. So one of the most common or well-known Pythagorean triads is the 3, 4, 5 triangle. And if you were to construct this triangle, you would find that measuring this angle would indeed give you 90 degrees, therefore proving the formula. So if we fill these numbers into our Pythagorean formula, so here we have C equals 5, A equals 3, B equals 4, we'd find that we get 5 squared equals 3 squared plus 4 squared. And if we simplify both sides, we end up with 5 squared is 25, 3 squared is 9, 4 squared is 16. We do in fact get 25 on both sides, showing that at least for this Pythagorean triad, Pythagoras' theorem holds true. So that's what Pythagoras' theorem is. It basically allows you to, in a right-angled triangle, knowing two of the side lengths, to calculate the third side length. So if it's the hypotenuse in the triangle, then you would make C squared the unknown in your equation, and you would substitute in the numbers for A squared and B squared, and vice versa if it's A squared, if it was A or B that was unknown in your triangle. So it allows you to always utilize the relationship between the 90-degree angle and all of the side lengths to calculate the unknown. That's all for this video, guys. In a future video, I'll go into some more depth around Pythagoras' theorem, and we'll have a look at the derivation and possibly proving it as well. Let me know if you have any other questions in the meantime. Thanks for watching. Bye.